exploring periodic data. All right, so the first thing they do is they define the word periodic function or the words periodic function. It repeats a pattern of Y values outputs at regular intervals. All right, so a periodic function. In science, you would look at like sound waves. Sound waves represent periodic functions. All right, if you've ever studied. All right, so somewhere in science you would have studied sound waves, which is a periodic function. It repeats a pattern. One complete pattern is called a cycle. A cycle. So one complete pattern of your graph or of your wave or function or whatever you're looking at is a cycle. A cycle may begin at any point on the graph of the function. The period of a function is the horizontal length of one cycle. Okay, so one complete pattern is a cycle. How long it takes to complete that pattern is the period. Okay, so if you think about sound waves, you have high pitches, right, that bounce back and forth really quickly. And so one cycle will look the same as a deeper tone, right? But it'll just repeat more often, so it'll be a shorter period. If you stretch out that tone, a deeper tone is going to vibrate slower, right? And it's going to still be that wave look, but it's going to take longer to complete that one cycle, all right? And so period is how long it takes to complete one cycle. It says analyze the periodic function below. Identify one cycle in two different ways, then determine the period of the function. All right, so if this is a periodic function, you should see the cycle more than once. And so they just showed two parts of the cycle. Here's one cycle, right? And here's another cycle. They just picked it up at two different pieces. It's okay. They just started at the top, down and back up to the top. And here they started right here on the axis, went up, down and back up to the axis, right? Both of those should have happened at the same length of time. And so if you look at this one, this started here, right? And where is this? This is at 1, 2, right? 3, 4, 5, 6 is where it ended, right? So how long is that cycle from 2 to 6?
4 seconds.
It is 4, right? And then this one started at 8 and ended, as expected, at 12. 4. That's how it should work. So identifying the cycle and then figuring out the period of the cycle. And so the period here would be 4. So go ahead and try A and B there. Let's look at these together. So you could have done the cycle multiple ways. Let's say we did the first one from this little loop right here, right? That's a complete cycle, correct? Do you see where it's a complete cycle? It starts, it goes up, all the way down and back up, and we're back where we started from. And so if we did that one, we would have started here at -4 and gone to 0, right? If we looked at another piece of it, let's say we start at the top and we go all the way down and all the way back up to the top. Then that one starts at 1 and ends at 5. Both of those are how long? 4. And so that is your period. And you could have chosen any two groups. They did -3 to 1 and 0 to 4, right? But any 4 are going to be a cycle. To the next one. So this one, depending on how you did it, you could start at the top and go down and back up to the top. And so for this one, we started at -3 and we went to 0. Okay? Or you could have started at the bottom, up and back down to the bottom if you wanted to. And here that's 2 to 5. Either way, the length of that period was 3, right? No matter where you did it on the graph. So if we look back at the definition of periodic cycle, it repeats a pattern of Y values at regular intervals, all right? So it repeats a pattern of Y values at regular intervals. And say they want us to show whether or not these are periodic, all right? And so if I'm talking about my Y value, if I look at this, this looks like a repeated pattern, right? But it's not repeating my Y values, right? Because I have a Y value of 2 and then what looks like about 2.5 and then 3, then about 3.5, 2, then 2.5. Like it is making a pattern, but it's not a periodic. Periodic should come back to where I started from, and you literally should just be able to translate it over left and right and put it on top of itself, okay? And so if I cannot translate it left and right and sit it on top of itself, it is not periodic. And so for this one, if I were to translate it, by that I mean take a chunk of it and move it from, like, take this chunk and move it directly over, you can see that I am not sitting on top of itself. I have to shift it down and right in order for it to work. That is not periodic. You need to be able to translate just left and right for it to be periodic. So this first one is not a periodic function. While it is a repeating pattern of sorts, it's not periodic. Let's look at this next one, okay? So for this one, I start here at 0. I go up to 2, back to 0, down to -3, right? Up to 0, 2, 0, -3. So this one is periodic. In fact, if I were to take a chunk of it, I can take that piece right there and I can slide it directly over, and you can see that it fits perfectly on top of itself. I translate it left and right. So yes, this is a pattern that repeats over and over, and it is periodic. Just left and right. So if you can just slide it over and it be the exact copy of itself, it is going to be periodic. It repeats if you look, if I wanted the period here, if I start here and go down, up, and around, and back up, then you can see that I am, and this every 2, by the way. So this is 1, 2, 4, 6, 8, 10. So the period here is 10. It repeats itself every 10 units. All right, so determine whether the function is or is not periodic. What about the first one? Yes or no?
No.
No. Second one?
Yes.
And what is the period? 4. So if you start, listen, if you start here at the -2, you have to get all the way to +2 before it repeats. So that is 4, -2 to +2. All right, let's look at this. Amplitude. This is a new term. The amplitude of a periodic function is half the difference between the maximum and the minimum values, okay? And so if you were to draw a line directly in the middle of the graph, right, and that's what this dotted line is, that's directly in the middle, how far you go up and how far you go down is going to be the same because it's directly in the middle. So your maximum here would be these points here. Your minimum would be this point here. And if you take from your minimum to your maximum and divide it in half, that is your amplitude. It is how far away you are from the direct center of the graph. Direct center. So in this case, the maximum point here is 3. The minimum point here is -1. All right? To find the distance between those two, you just subtract. So 3 minus -1. The distance between those two is 4, and then we divide that by 2. So my amplitude for this guy is going to be what? 2. All right, amplitude. So I go 2 away from the center. Amplitude is how far away you are from the exact halfway point. The way you find it is take the maximum, subtract the minimum, and divide it by 2. All right? So let's look at example 3. Example 3. Find the amplitude of the periodic function at the right, all right? So the first thing we're going to do is figure out what our maximum is. What is our maximum here? 4. All right, what is our minimum? -2, and we are going to divide that by 2. So 4 minus the -2 is 6 over 2, which gives us a amplitude of 3. Let's look at these. The first one, amplitude. What was your highest value? 1. What was your lowest value? -2. So you should have gotten 1.5 as your... All right, what's the highest value of this one? 3. These are every 2, if you didn't notice that. What's your lowest value? 0. So again, you should have gotten 1.5. This says sound is produced by periodic changes in air pressure called sound waves. The oscilloscope at the right shows the graph of a pure tone from a tuning fork. Find the period and the amplitude of the sound wave. So I'm doing it this way because the example that you do, it asks you to graph it. So what we're going to do is we're going to look at the description. It says one cycle, if you look on in your book, one cycle of the sound wave occurs from 0.03. So from 0.003 rather, to 0.0075. So we're going to assume that every one of these units is 0.001, okay? So when you see a 1, it's a 0.001, etc. So it goes from the 3 to the 7.5. All right, they just told me that's where it occurs, right? One period goes from 3, or one cycle goes from 3 to 7.5, all right? So then how do I find out what the length of the period is? If it starts at 0.003 and goes to 0.0075, how do I find out my period? Yeah, subtract. So I'm going to say the period is 0.0075 minus 0.003. My period is 0.0045. That's my period. All right. Then it tells me the maximum value is 4 and the minimum value is -4. All right. So my maximum value is 4 and my minimum value is -4. So what then is my amplitude? How would I find that? My maximum is my 4. My minimum is my -4. So I say 4 minus a -4 divided by 2, which is going to be 8/2, which is 4. Amplitude is 4. And then if I were to sketch this, assuming it's a wave, okay, then I can assume that if I start at my highest value, which is what they want me to do, I'm going to have to go somewhere down to my lowest value and up to my highest value. Isn't that beautiful? Beautiful wave there. I know. I'm trying to figure out where it starts. Oh, it starts way down here. Starts down here. There we go. Right, it's going to do something like that. Yes. Some type of wave. All right. And so that's what your wave's going to look like when you get through to your highest value, lowest value. And it'll probably shift a little because I didn't get it up here where it should be. All right. So if it takes a period to go through and goes to your highest and your lowest, it should be something like that. So look at the check understanding. Sketch the graph of a sound wave. They gave you a new period and a new amplitude. So they want you to sketch that graph. That's better. Looks better like that. There we go. High and low of 4. And it waves back and forth. So if you start at 0, your period is 4. So it should complete a cycle in that sound waves go all the way up and all the way back down. So your highest point should be 2. Your lowest point should be -2. All right. So if you think about it logically, it should go all the way up and then should go all the way down. So we should go all the way up to 2, and then we should go all the way back down to -2. So it will look something like that. And it could be shifted on the graph if you started someplace other than 0. I just started at 0. But one cycle should take 4 units to complete. It should go all the way up to +2 and all the way down to -2 if you started at 0.